All right. Good afternoon, guys. Let's see if we get my camera going. There we go. Okay, so today is fairly similar to last time. We're basically just going to work on Flappy Droid a bit. It's mainly going to be about like game manager type stuff, some spawning things, and a little bit of state pattern stuff. So I think on here, so on Blackboard, I did upload for the same place where the lecture slides are. I did upload the state C# file that we worked on last week. If you have your own version somewhere that you wrote along with me on last Thursday, then that's perfectly fine as well. But I did upload the version that I had as well, in case you want to grab that one, because we will add it to our project. So right now, if I just took that file and I just dragged it in, so I do have it as part of the project. There are a couple errors because I didn't change anything. So before we start running the program, we're going to sort of clean out that state file and then those state classes, and then we'll sort of continue on with the coding that we need to do. So slide-wise, there's not a ton of slides today. It's mainly just sort of showing that this is how we're going to do some spawning. This is how we're going to do some like game over type stuff. We'll make a few updates to some of the scripts that we've already written. So really the slides are more or less just sort of showing these are the changes that we're going to be making. These aren't like hard and fast rules of you have to put this in like this and you have to do it like this. This is just a way that we are going to approach it. We will be using the state a little bit. So I have a couple slides on how we're going to make some changes to the state pattern. But for the most part, there's just, I think in the PDF, since I do sort of the 4 slide pages, I think the PDF's only like 3 or 4 pages long or something. So so it's not a lot of slides. It's just we're going to be hooking stuff up. So we're going to be messing around with the inspector and dragging stuff in and writing our slides and stuff and writing our classes. So let me start up that. See if I get that pen tension thing here. The little thing that I'm using for the So that should be good. So move stuff around here. My second monitor. There we go. Okay. So game manager wise. We need to create one. We're going to put the spawner in there. You don't have to do this. You could write a separate spawner class. This game is simple enough to where the game manager, I'm just going to put the spawn in there. So we have a lot of similar things to what you saw in Volcano Island. And we even have a little bit of state in here. And so we'll talk about that when we get to the state machine. So there's really sort of 3 parts to this. For the game manager, there's sort of 3 parts. There's a prefab for the pipe. So we have that sort of one segment of pipe. We're going to drag that in. So I'll probably make that public. We have the player controller, just called player. So we'll probably drag the player into that as well. So we'll likely make it public. I'll make a couple of these public as well. So spawn range, we'll talk about what that means. Time between spawn, so like number of seconds between each pipes. And then the spawn time will probably be the private variable because that's the one that's sort of counting up. And then you spawn something and then it counts up again and spawns and so on. And then a little bit of state, which I'll probably make public. Maybe we'll write a method or something, or we'll have it be a property or something like that we can mess with. But this will be sort of the main things that our game manager contains as far as variables go. So we'll have some functions to help us out with sort of state as well. So things like game over. What happens when there's a game over? Well, we're going to make the player object be not active anymore. And we're going to set a little bit of state. Like I said, we'll talk about this more when we get to the actual state machine itself, but I have a couple of Booleans in here to sort of help us out before we add the state machine in, and then you can sort of decide what you want to do with these Booleans afterwards. So something like this dot moving equals false. When you die, everything should stop moving. That's basically what the variable's there for. There's a reset as well that makes it so you're not dead anymore, and I'm probably missing this dot dead equals true or something somewhere. I think maybe that's at the player class. But moving equals true. We set the game. We set the player to active, and we set the player's position back to 0. So just some reset stuff to get us back to where we were to potentially play again. So having a function to do that, even though we're not necessarily going to use it today, if you add a reset option into your game, this would be something that you would definitely call. And maybe a method, this is kind of redundant with game over, but it lets us do some other stuff as well. So when the player dies, we call game over. And maybe here you play a particle effect, or you play some sound, or maybe you have like a little bit of death music or something, and so you play the death music. So even though game over and death look similar in terms of what they're supposed to do, like why have, you may have a situation where someone wants to quit playing, and so you may call game over at that point, but not want to call it death, for instance. So it might be worth having these sort of split up, death versus game over. So we're going to add some of that stuff to a game manager. In addition to that, we are going to, so we can add more flair, more functions, break some of this stuff out a little bit more later on. But we're also going to do the pipe spawning. So I'm going to talk about what this code does when we get to that point and when I actually sort of code it up. It's going to be very similar to the Volcano Island sort of spawning that we do, but we have to spawn a top pipe and a bottom pipe. So specifically, there's 2 instantiate functions here, because we're going to instantiate one that's on the top and instantiate one that's on the bottom, and make sure that there's a gap in between them. So that's something that we're going to deal with here. And like I said, this will be in the game manager. So we could create a separate spawn manager if we want to, but this is fine for the small game that we're writing. So I'm going to go into Unity. And the first thing I'm going to do before creating sort of anything else is I'm going to go into this to my little state class here, and I'm just going to clean it out. So again, this is the one that I grabbed from the same place as the lecture slides that I uploaded. So we got a little bit of cleaning to do to make sure it sort of represents what we want. For now, a play and a game over state in here is perfectly fine. So remember that the abstract state class contains the states that we're going to have in this machine, and the rest of it you can pretty much leave alone, because everything here sort of is sort of how we initially set stuff up. So exit, update, enter, those are our 3 different types of sort of things, the states that we can be in within a state. So that's why I call it events. So it's an event that's happening. And we have our virtual functions that we're going to override, and we have that process function. So in the play state, I'm going to delete some of these prints because we don't need them unless you want to see what's going on. And then I have a few things in here like game manager and stuff that's trying to do something, which I don't have a game manager yet. So we're going to go ahead and remove that. Just remove that completely. And then I'll get rid of the print here and some of this other stuff. For the game over state, I'm going to do the same thing. I'm just going to delete a few of the things that we already had in here. We will put some stuff back into this a little bit later on. Okay, so the state machine should be pretty much cleaned out, so we can just start adding things that we need to add. And hopefully not have any more sort of error things pop up here. I do have a warning. That's likely because I'm using the require components and creating a rigid body. It's not going to cause any problems for us at the moment. Okay, so I'm going to right-click in my scripts folder, and I'm going to create a new script. And this is going to be the game manager. And we'll let it do its sort of initial compile thing. Right? I think I still have a pipe in the scene here. Yeah, so I'll probably end up deleting this pipe. I don't need this. We already made the prefab, so I can delete it. And I need somewhere to put the game manager. So I'm going to create an empty. And I'm just going to call this game manager. And I'm going to take my game manager script and drag it on there. Sometimes you'll also see people taking a manager type script, like a game manager or an audio manager or something, and putting it onto the main camera. That does work if you always intend to have the main camera in the scene. I like to have it in a separate game object so that it is completely separated and I'm not going to the camera to find the managers. But if that's something you want to do for sort of a smaller project where you don't want to add a bunch of game objects to be sort of separate managers or something, people do put it on the main camera. I've seen that before in like tutorials and stuff. So let's go ahead and open up our game manager here. We need to add in all of the singleton stuff because that's what I'm assuming with the code that's sort of have on the slides. So we need to make a private static game manager called instance, and we can throw in that awake function. And we'll set this here equal to null. And so we'll say if instance equals null, and instance equals this. And we'll have one last function. Let's see what he complained about here. Yes, don't need the parentheses there, of course. And then we'll have our public static instance. Now we'll have our instance function here. Public static game manager instance. All right, so make sure you have that sort of singleton stuff in there. I do, when I write my classes, I do kind of like to keep this separate. So I like to be like, okay, this is the singleton parts, and then I'll put all the rest of the stuff here. That way, if I need to go in and mess around with the singleton part, maybe I want to make it a little more robust, or maybe I want to get rid of it for whatever reason, I realize that I don't need it and it's just messing things up, then I can just come in here and delete the first part of the class and I'm good to go. So that I don't have to worry about it. I don't have to worry about looking through my code and trying to find each of the individual components. So that's what I like to do. If you don't sort of like that idea, then you can organize it however you want to, but this is typically how you'll see me do it. So the rest of the class is here. So these are where we're going to put the rest of those variables that we need. So we'll have things like a public game object called the pipe prefab. So we'll drag that in. Same thing with the public player controller. And I'm just going to call it player. So we'll drag that sucker in there too. And then we'll create a couple of floats. Let's see, I think I had spawn range. I'll give it a default value. I think the default value was like 3 or something that I had in the slides. I'm going to need another float. We'll make these public here so we can adjust these. Public. And I'll do something like spawn, maybe like time between spawns. Have that be 3 as well. And then a private spawn time. Start that at 0. So private float. So the purpose of these 3 are just to deal with the separation and the sort of the delay between spawns. This is going to be our actual timer for spawns. So again, it's similar to what we did in Volcano Island. The last 2 we're going to have are, I guess, maybe I'll use a property for them. So I'll make them private here. They're just going to be Booleans, and we'll call this one dead. And we'll do maybe we'll have them be public, I guess, so we can sort of access them and sort of have them be a check mark. That's what a Boolean is. It's just a check mark in the inspector. That way we can mess around with it while the game is running to make sure stuff is working correctly. So we'll have a get and a set. So we'll make them a property like this. And the same thing for the moving. A get and a set. So those will be our variables. These are things that we'll mess with. These are things that will help us use the state machine as well and determine what we need to do. Do we need to play a particle system? Do we need to, when do we need to spawn things? How far apart are the pipes going to be? That sort of stuff. So along with this, we can write a few of those little helper functions that are on the slides. So something like public void game over. So we call game over. That's going to take the player. So that's my player controller dot game object. So that's a game object it's attached to dot set active false. So the player object is going to disappear. And then in here, we might have a to-do where we need to play a particle effect or play sound or do something else. Maybe show game over screen or something. or switch scenes, whatever. So whatever you want to do here, when there's a game over, this is something you can do. I didn't put the particle system one in here because I remembered that we have a public void death. So this should probably call game over. And then maybe it could do something different as well. It could play a particle effect or a sound, whatever. Yes, I am separating them out, but again, you might have different things you want to do depending on how the game over is achieved. For the death, you probably want to play a particle effect and a death sound, an explosion or something, right? For a game over, you may not necessarily want to do those things. So whether or not you end up using these for the assignment or whether or not we end up using these for the game today, that's a question for how far we want to go with it and what we want to do. I think the last one is reset. We're not actually going to have a reset state. I don't think it might be in the slides, but we're likely not going to completely program one. But it is one that I want you to think about. So we might have a public void reset. So this would be sort of resetting the state of the game, and it's something that you would call, for example, if you were in the game over state in our state machine. If you go back to playing the game again, if you make a quick menu item and you press a button and you go back to playing the game, you're going to want to call reset. So that could be the exit. That could be something called during the exit of the game over state. Or maybe we could call this during the entry of the play state, for instance. So that's something that potentially we can look at as well. I think the code for this was just setting a bunch of these Booleans. So this dot dead equals false. This dot moving equals true. You'll see where we move this moving here in just a second, or where we use this moving in just a second. We probably want to make the player dot game object dot set active. Probably want that to be true so we can see the player. And we probably want to reset the player's position as well to be whatever an initial position should be for the player. For us, we're going to do player dot object dot transform equals a vector3 dot 0. So that's just a vector3, a static vector3 with all zeros. This should be dot position. So just resetting the player, nothing special there, and potentially we can include that in the entry of our play state maybe to make sure that that's working properly as well. The last piece of the game manager is spawning the pipes, and then I'll sort of slow down a little bit and ask if folks have questions, because I do want to get through the game manager, through the spawning and stuff, so we can get to the state machine, because I know that was not. The stuff we went over on Thursday was a little bit more academic, so this time I want to actually sort of show it in action, show how it's actually working. So that's what I want to spend more of today on. So spawn-wise, let me go back to we'll just put it in here. We're going to do public void. Let's call it spawn pipe. So we're going to call this every frame. So you might want to name it something different, maybe check spawn or something, whatever, but it's going to be called every frame. That's my intention here, because we're going to have an if statement to say, okay, if my spawn time, if that's less than or equal to 0, then we're going to do all the spawning. Otherwise, we're going to, this should, that's fine. Otherwise, we're going to take the spawner, the spawn time, and we're going to subtract the time dot delta time. So every single time, this spawn time value is going to get smaller and smaller. And it helps if I spell it right. In addition to spawning the pipe, which we're going to do in a second in this if statement, there's one extra piece that I need down here, which is spawn time equals time between spawns. So once we do a spawn, we need to reset our spawn timer. And so this should be familiar from Volcano Island, but I just want to make sure that everybody understands how this works. If I call this every frame, which is the caveat here, then I can subtract off a little bit of time from my spawn time variable, and whenever it's less than or equal to 0, we do the spawning, and then we reset it to some larger value, which right now, sort of by default, will be 3. So that's how that's how my spawner works. But it is important to know that it is called every frame. Otherwise, this won't spawn it on sort of 3-second intervals. All right, so we need some information related to our pipes, because remember, we're sort of doing something like this, and I can maybe draw some kind of ASCII thing in here, right? So if I use the pipe a couple times like this, we want to have a gap, and however big that gap should be, and we want to make sure that we're spawning a top one facing sort of the correct rotation. So instead of being sort of like this with the top here, we want it to be sort of rotated completely over. So there's some rotation that we need to think about. And there's this sort of gap we need to think about. But remember, and I'm going to go back to Unity. And we're just going to drag a quick pipe in, and I might fill in the game manager stuff in here. I should fill in some of these values. But first, I want to look at the pipe. So if I drag a pipe in, notice that the pivot, the place where this would rotate around, the X, the place where this rotates around is that sort of edge. That sort of, it would be the top if the pipe was facing down, and it would be the bottom if the pipe was sort of up, was sort of a top pipe. So this is something that I can just move. If I move the Y, it's going to be exactly pivoted here, and it will be rotated there. So if I rotate this around, I put this at 180 or something, and I move it down, the rotation's correct, and the position will be correct if I move it down in a little bit in Y. Just like for the top one, if I keep it same rotation it has and move it positive Y a little bit, I will get that gap. So there is a couple things that we're going to do here to make sure that we get a useful gap. And it does depend a little bit on your geometry. When I created this pipe, I did it in the Asset Forge program that I showed you last time. And I went into Blender and I ensured that the pivot was where I wanted it, right here in the right on that edge. So I did have to mess around with it a little bit in Blender, and then I exported it as an FBX, and then I brought it into here. So the pivot was where I wanted it. So it's one of those sort of 3D model sort of complications that comes with things. The pivot is actually important depending on what you want to do with the object. So let's see. So let's fill in. And we have our prefab here. So let's grab the game manager. And in the inspector, I'm going to take my pipe prefab, not the model, but the prefab itself, and I'm going to throw it in there. And the player, I'm going to grab the player and throw it in there as well. So I have those filled in, and we'll keep this spawn range and spawn time stuff in there. Both being 3 as is. So back to our code. There's another complication to this as well. If I have another pipe, I might want a different size gap, and I might want the opening to be in a different place. So I might want something like this. So we got something where we have the opening here. We fly through that, and then later we're going to need to fly through maybe a smaller opening, and that opening needs to be in a different position as well. So that's what a couple of these variables are going to help us out with. Specifically, the spawn range variable is actually going to help us out a little bit with that. There's another variable we could add in as a public variable that deals with the spacing, but I'll show you where that actually happens as well. So let's make a float for the Y position of the top pipe. So the top pipe Y position needs to be sort of somewhere, and then we need to spawn it. And then based on that, we'll spawn the bottom pipe. So we're going to basically put the top pipe where we want it, and then spawn the bottom pipe so there's a gap. So let's make let's use a random number. So we'll do random.range. I'm going to put in 2 floats here. This is where the spawn range comes in. Negative spawn range to positive spawn range. So think about what that does. If the 0 Y position is here, and my spawn range is 3, then I'm going to allow the bottom position of my pipe to be anywhere from positive 3 to -3. So I'm positioning that top pipe where I want it. And I'll do the instantiation here in a second. And then I will spawn the bottom pipe based on that. We also need a float for the X position. So the X position of the top pipe, I'm going to put that at, I don't know, we'll pick a value for it. I'm going to put it at 30. We'll probably change that. I just need it to spawn somewhere to the left or somewhere to the right. Spawn somewhere to the right of the player, just so it's off the screen. All right, with that information, we can actually do the instantiation. So I can instantiate. And we want to instantiate the pipe prefab. And I'm going to create a new vector3. This needs to have X, Y, and Z. Z is just going to be, we'll just leave that at 0. So I'm going to take X top, Y top, and 0. We'll keep it at 0 on the Z. If we need to change that, we can. And then for the rotation of this, the pipe is already set up to where that sort of edge thing is already facing down. So we don't need to do any rotation. So I can still use that quaternion dot identity. So it's going to spawn it just like what a prefab looks like. We can add some rotation into this though, and I might point that out in a second. We'll get a little variation. We could get a little variation with it. That's our first pipe. That's our top pipe. Now we need a variable for the bottom, the Y value of the bottom. So float, I'm going to call this one Y bot. We don't need an X bot. The pipes should spawn in the same X location. So with the Y top or with the X top, we already have the X location for the bottom pipe. So we only need to worry about this Y bot. We're going to base Y bot on Y top. So I'm going to say, okay, if I just did this, Y bot, Y top. If I just did this and did another instantiate, but did the rotation. So we'll talk about rotation in a second. So imagine that I have the correct rotation in here so that it's sort of facing down. Then I'm going to have pipe that looks like this. There's no opening because I've spawned my top pipe here, and the pivot being this edge means that if I do the correct rotation, it's going to rotate down, but I've kept it at the same location. So I have a pipe with no opening. So if I do this, it's a pipe with no opening. So now I need to force an opening. Well, how do I do that? I shift the pipe down. So I subtract something off of this. This is where you can decide some randomness. So maybe my base is something like 2. If I do this, then I always have every pipe sort of set, every top-bottom pipe pair will have the same gap. It'll have a gap of 2. That might be what you want. If you want some variation, so some are a little bit wider, some are a little bit shorter, this might give you a baseline. Then we can subtract maybe a little more. Maybe this is the smallest I want the pipe. So then I can say, okay, let's do random.range, and random.range. Maybe I want this to be 0 to 2. So it'll either be 2 elements in size, or it'll be a little bit larger. It'll be sort of either some value or double that, and sort of anywhere in between. That's the idea with this. So I'm basing everything on the top pipe, and I'm just shifting the bottom pipe down to create an opening. That's all that I'm doing here. As far as rotation goes, I need to rotate. In this case, I'm going to do it in the X, and that's something that you can mess around with in the inspector, like what we did. We showed the pipe sort of rotating. I'm going to rotate this in the X. The way to do that, the easiest way to do that for this is to say quaternion.Euler, and then put in the rotations that you want. So for us, we needed the X to be 180. The others could be 0. So this gives me the X rotation of 180, just like we saw with the pipe. When I rotated it 180 in the X, it was facing the direction that we wanted it for the bottom pipe. And that's basically it. That's how we can spawn the pipes. So they'll be in different locations. The pipe pairs will be sort of shifted based on spawn range. And it'll be a gap between them will be based on Y bot. And actually, I need the Y bot here in my vector3. And that'll be it. That's our spawning. So what I'm going to do is back in Unity, I'm going to take the player and I'm going to turn the player's gravity off so that we don't have the player falling and the camera following that. And I just want to see if everything is spawning. Let's see if the spawning was working here. So there we go. Up. Yep. One last piece in update. And I don't think we have an update because I think I deleted it. So in update, which I'll put right above game over here, we need to make sure that spawn pipe is being called. So it is called every frame, so we actually do it. So there's my spawn pipe. This we will move. The reason why I didn't mention this in the slides about putting this in there, because we are going to move this spawn pipe to our state machine. So it's something that we will change a little bit later. Can't drag a pipe prefab in the game manager, Joey. Make sure that you definitely want to make sure that this is just game object rather than anything else, and make sure that compile here. It might be something we need to look at afterwards. If you click on the little circle with a dot in it, you should be able to see your pipe prefab in the list. If it doesn't show up, then it could mean that this isn't showing the correct that this type isn't correct. So this should say, when there's nothing in it, it should say none game object. And the camera setting wise, that's something we will mess around with a little bit later today. After we do the state machine, I'll switch back over to the camera and sort of show what the camera's up to, because it's probably something we need to tweak anyway. So let me throw that back in there. And Joey, we can potentially take a look at that after class, maybe, if you can't quite get it working. Okay, so let's try it again now that we have the game manager in there. So here's our pipe. We get a little bit of motion. Notice how if we pause here, we have a little bit of motion in here. So like this one, for example, is I think a little bit wider than this one is to fly through. We get a little bit of that sort of shifting motion. The random number generator here is a uniform random number generator. So we should get, if you were to spawn millions and millions of these, we should get an even number at the highest range and the lowest range. So get the same amount in sort of all the different ranges. So we don't have any sort of collision stuff set up yet. That's something that I skipped last time, so that's something we'll look at. And yeah, here is the pipe spawning. So you should see something like this. Yeah, Nathan. So I think the reason potentially take a look at your the Unity Engines version. So there's two different versions of the random. I don't remember if this is the system version. No, this is the Unity Engine version. Definitely make sure you're using you have using Unity Engine. That's definitely needed. You can also try this if you want to. You can also put Unity Engine, this, and it should be able to pick this up as long as that is part of your assembly, which may mean you have to regenerate the project files if you're using VS Code, for example. There is also a system one as well. So you could try the system one, but I think it doesn't have a range one. It might be using the system one automatically for you or something as well, which is why, because I think it's named something different, but there is a random number generator for the system as well. But this one should be the Unity Engine version that we're using. I think if you're using, so I think if you have up here, if you have using system, I think it will automatically use, so Ryder looks like it did the import there. So so the reason for that is because there is a random for system and there's a random for Unity Engine. And so if it uses that system one, you can force it to use the Unity Engine by doing that. Okay, so you should see something like this. It's depending on the ranges you pick and the spawn time you pick between stuff, it's going to look different. One of the things to note also is that they're all rotated the same way in the, I guess let's say in the Y. So there's no variation like where that handle is. That's something that you could mess with. So here in my spawner, I could say, so it's in the Y. So I could say something like, well, let's rotate this one 90 degrees. So all the bottom ones will be rotated 90 degrees when they spawn. Rotated 90 degrees in the Y. So when we do this, see that, here we go. Now the handle here is always going to be facing sort of towards us, towards the camera. So that should give you a little bit of inspiration as what happens if you put a random number in here. Then you'll get a random rotation, and it'll give you a little bit more variety for where that handle's sort of pointing. And you could do the same thing for the top as well. So consider that. I'm not going to code that up. It's just another sort of thing we're basically just generating another random number and then putting it in there for it, and putting in, maybe generating two random numbers and putting one for the top, one for the bottom. In the end, it doesn't matter for what we're doing right now, but it adds some variation to the game. So definitely use random numbers to do that sort of stuff. Okay. That's the basic spawning. That's pretty much all that we need sort of spawn-wise. We should check to make sure that the collision would actually be happening with our player. So in the player controller, I'm going to write, and this was a function that I think I had mentioned that I think it was in the slides from last time. We're going to do the on collision enter and make sure the correct one here. Yeah. So we're going to use on collision enter. It needs to be the 3D version because we have 3D stuff going on. For now, let's just do a print. And we're going to say hit. So we hit the pipe. So let's make sure that works. We should have everything set up for it, although I'm not 100% sure. So if it doesn't work, then we're about to find out. So we likely won't be flying through all of these just by sitting here, but we flew through that one. This one should hit. Doesn't look like it registered, so we'll check and see here in a second what might be going on. Let's look from a 3D view. Okay, so it looks like from a 3D view, it looks like we should be hitting them. I did mess around a little bit with the colliders. So here, my collider is sort of all the way around this, so that should be the collider for that one. And if we look at, for example, one of these pipes, here, that should be the collider for that guy. We don't have any sort of is trigger stuff on here, so it's not sort of acting like a trigger. And this guy, we have the rigid body, where I turned off gravity, but everything else should be okay. So let's see about if you remember from last time, this was off, like the box collider was like slanted and all that kind of stuff. I just made sure that I was rotating just the graphic. So my graphic is rotated at some angle. I think it ended up being, in this case, like 71 degrees or something. And then my player, which had the box collider on it, is all just set for rotation at 0. So it's some of that rotation child versus parent sort of thing. So I would say that this should be giving us hits. So let's go to our prefab here. And I'm going to add a box collider. Let me check real quick. Make sure I didn't add something I wasn't supposed to. So let's add a rigid body to the pipe prefab. I'm going to turn off gravity because I don't want them doing any gravity stuff. The rest of it should be fine. So back here, and we'll see here. There we go. There we got our hit. Notice that it causes us to sort of bounce around. Not necessarily something that we want. So that might be something that we need to mess with. But when we do hit something, we should die anyway. So it's probably okay to have it that sort of interaction actually take place. But that's why we got the hit. That's what we were looking for. We were looking for this hit to show that we registered this. And so what we can do is we could say here, when we have a collision, let's inform the game manager. Game manager.instance. I don't know, death, maybe we can call death, or we can just create the dead to true, for instance. So we set dead to true. Maybe we should call death as well. That's probably a good idea. Maybe we could have the state manager deal with the dead as well. Or maybe in here, I could change this. Dead equals true. Add game over in the game manager. That way here I can just call death. So I'm going to print hit, and I'm going to call death. When death gets called, we set dead equal to true, call game over, game over, and to play a particle effect or whatever if we want to. Or we can play the particle effect from the on collision enter, play it anywhere we want. So here, maybe play effect here. It's up. It's essentially up to you. So yeah, so that's then that sets the game object to false. Let's set active to false. So what we should see do this is as soon as we hit something, so it should be coming in here. As soon as we hit something, boom, done. Now the pipes are still moving. They don't disappear or anything. They don't stop moving. We should probably have them stop moving. That's what the moving Boolean is going to be for. So we're going to have a little bit of state here. So if whenever death gets called, maybe we can say moving equals false. So the last thing to cause these pipes to stop moving over here, in our fixed update, we can check the game manager. So if moving equals false, then return. This is state. This is something we could put in our state machine. So I'll talk about that here in just a second when we write when we mess around with the state machine. So now those pipes, if they see the game manager say moving is false, then those pipes aren't going to move. They're not going to run this piece of code. That's the thing that I called a guard statement, right? So it's sort of guarding the rest of the code. If something isn't what it should be, then it sort of guards it and doesn't let it run. Okay, we got a nice spinning pipe there. So that's a bit odd. So let's see what's going on. Yep. So they were not moving. I think I have that. I got that wrong. Andy, yeah. So yeah, I had something wrong here. I'll have to see if I can flip that around. Yeah. So Andy, I had it set. I did set it to a public. I should be able to set it to private as well and still use the property. So the private property here should still, or the private should still work here. But it has a get and a set. Sometimes folks write a separate thing for this. You can sort of look this up as well. You can write a separate variable. I think I showed it when I was showing off properties a few weeks ago. But you can write a separate variable that does stuff with this, but it should still work with the set and get. It's just that sort of property thing in C#, just with this get set thing. Okay, so what I have here, so I think I don't ever set this to start with. So in start, let's say moving. Actually, let's just do. We'll probably move this in the state machine, but let's just do a reset at the beginning, so that we reset. We make sure dead is false, moving is true, and everything's sort of where it's supposed to be. Makes sense. Again, we'll move this into the state machine in just a second. But for now, for sort of testing purposes before our state machine, we'll see what's going on. Yeah, so it doesn't like the private there. So probably what we would do in this case is you could keep this private, and you could actually make a property out of this that's public. Make a public dead. This is often how folks do this. Public dead. And then you would have like a separate get. You'd have a separate get that would be dead equals value or something. So you would do something like this. For now, I'm just going to keep it public so we can get to it. We could write another method as well. So we could write a getter setter pair, but I'm going to keep it public for now. Just means we can write a bit less code. and still get the functionality that we want. So it should be here. Oh, yep. I just changed dead. Let's change moving as well. Compile. Go. Now they should be moving instead of spawning on top of each other. And what we should see is like this. So we get that. This guy does move because it does sort of bounce a little bit. And we're likely still spawning over here. So there's some more state stuff that we probably have to deal with. If we're dead, then we shouldn't be spawning. So you can sort of see where this could cause a problem as far as adding more states. And this is where we're going to stop putting the Booleans in. Because I could add something here in my spawn pipe to say, okay, if dead equals true, then return. But this starts to become a giant pain because now you've got to deal with these Booleans everywhere and what you want to happen during the sort of true false stuff, whether these variables are true and false and what combination of true and false need to be in order to spawn. And this is why we're going to use a state machine here. It's not a huge it's not a huge need to use a state machine in this game, but hopefully it will help you understand why the state machine can be important and how it can be used in an actual game. So on the slides, we have about 30-ish minutes left, so that should be good. So here's that fixed update that I added. That piece in there. Again, this could go in the state machine as well, so that's something that we can always talk about. That's that sort of guard statement thing. Player controller. So I had the sort of on collision enter. This I just had setting dead equal to true, but you saw in the thing we just wrote, I just called dead instead. All right, state machine wise. So again, we talked about this last week. I know it was a little bit more academic last week, so hopefully this will make a bit more sense. We have a bunch of situations like this. This isn't code for our game. It's just this is a bunch of situations we have. We're like, okay, if dead equals true, if moving equals false, we have all these sort of if branches. And if we need more state, we might have a pause state that we want to add. Maybe we want to have a state where there's the player's damaged or something, so we need to be playing. Like if they hit a pipe, maybe they don't die, they just start like smoking or something. We need to have a state for smoking, so we play the appropriate particle effect, and blah blah blah. It just starts to get a little bit out of control. So for a complicated game, or even for a simple game, which is probably the best way to start, we're going to use that state pattern that we talked about. So there are lots of different ways to handle this. And if you read the chapter from Game Programming Patterns, the author there does talk about enums and switches and stuff as well. They give you a little bit. It's sort of straight up enums and switches together. They sort of give you a little bit more control, but eventually you run into the same problem. It's that scalability problem. So that's why the state pattern is what we're going to use here. It's not 100% necessary to make this game work, but I think it's useful to see. And then in our next game, we're going to use it to deal with game state as well, and with enemy AI, specifically about a boss AI. All right, so we're going to use that state machine from last week. So that's the one that I posted along with these slides. And if you want to use your own version from last week, that's fine. At the beginning of class, of course, I sort of cleaned it out a little bit. In the slide here, I say play game over reset. We'll probably nix the reset for the lecture, but it's something that you should be able to add in sort of relatively easily. So our enum is going to look something like this. I'll just do play and game over for now in our main sort of parent class. In our play class, this is where I'm going to add a little bit of code to update and exit. And it's just a little bit, but it's the code for update here. It's the code that went into update. It's this, game manager.spawn pipe. So when we're in play mode, we will spawn a pipe. And that's almost all we need to do. We can check if game manager is dead. So the dead is true. Then we know we need to exit the play mode, exit our play state. And that's all I have to do. This is almost the entirety, unless you want to add a little bit more to this, this is almost the entirety of the play state right there, because it's the stuff we have in update. So back to our code. In Game Manager, Let's get rid of this if here. I'm not going to need that. In Game Manager, all I have in update is spawn pipe. In start, I have reset. So we will probably add that in as well. But I only have spawn pipe. So in my state machine, in my play state, I'm going to put spawn pipe. It'll actually be, I should probably grab a particular, I should probably make a variable for this so it doesn't have to grab the instance every time. But for a simple game like this, it's fine. So I'm going to spawn a pipe. So I can remove it from here. I don't need it in here. In fact, I don't even need the update function. If you have an empty start, an empty update, an empty awake, any of those sort of I'm going to use quotes here, built-in Unity functions, you should delete them. I might talk about why in the future, but you should delete them. It is a performance. It's a performance issue if you potentially have many of these. For a single game object, it's not going to matter. But for if you're spawning hundreds of a game object and they all have start, an empty update, an empty awake, all of that, it does cause performance problems. So we're just going to delete it. We don't even need it. Same thing with start. Where would I put reset in my state machine? I could put it here. When we enter play, I should put it here. So I could say game manager .instance .restart or reset. So when we enter the play state, we will immediately reset, which is kind of like start here. We don't need it. We will need something in start in a second, but we don't need here. And actually, I probably shouldn't have deleted update because we actually will need update. But for now, I want to illustrate moving the stuff over to the state machine. We also need to check if the player's dead. That's our trigger. When the player dies, that's our trigger to leave the play state. So if game manager.instance, and this is where if I would have stored a variable, then I wouldn't have to call it so many times. If game manager.dead, game manager instance.dead, if that's equal to true, then we need to exit. So that's where we're going to set. I think in the slides or something, I think I had first stage equals event.exit. So we're setting the stage now to go to the exit portion, which again could be something else. You could put in exit, you could put a scene transition, for instance. You could put display a certain panel. You could play a song, play some music, play whatever you need to do when you're exiting play mode. So you can put that stuff in there, and then all we need to do is return. When we go into exit, where do we go next? The only place I'm going to go is to game over. Now, if you had a pause sort of menu, so let me show you what a pause might look like here. So you might say game manager.instance. You might have a .pause. If that's true, then we also need to exit. But now there's two possibilities. We could go into the pause state or go into the game over state. So in here, you probably would leave exit sort of normal, sort of as is like this. And you would do something for the dead, you would say next state equals new game over. And then here, you'd probably have next state equals new pause. Something like that. Now, obviously, I don't have a pause state, but that is sort of one of the things you could do to do this. Otherwise, if we just have one possible state, which is all we have now, I could put this next state equals new game over. I could put that into here instead, because I know that from my play state, the only place I can go is to game over. So it depends on how many states you potentially could be going to as to whether or not you should put the next state equals that new state in the update or in the exit. So I'll just leave it here. So if you want to add another state in, like a pause state, you can do that. So as soon as the player is dead, we set the stage to exit because we're leaving the state, and we set the next state to game over. For the game over state, do we need anything in there at the moment? Maybe not. We could have something where if inputs dot get key down, maybe keycode.space, maybe, whatever. That triggers us to go to the exit. So it'll be kind of look like this. this right here, and maybe we go back to the play state. So we enter game over. We enter game over. We do update. So we're just waiting. All we're doing in this state is just waiting. Just waiting for us to press space. And as soon as we press space, we're back into play. And when we go back into play, what do? We do our enter. So we reset the player and all of the Booleans and stuff. And then we're back to spawning the pipes again. In here, we need, in our game manager class, now we need a state variable. I'm going to call this state. I'm going to call this game state. And this is going to equal a new play. Whatever state you want to be in when the game starts. So this could be a main menu state, for instance. Then I'll do the same thing we did last week. So I'll say game state equals game state dot process. Not there. We want this in update. So that's why we want an update. And for start, I likely don't need it at all. The game over back to play is not going to work properly. But will it work properly? It'll still, it's going to keep the pipes there, but I think the spawning will still sort of work the same way. So for update now, I don't have anything related to spawn pipe directly in here. Update will do this because we're in the play state. So this is all update's going to do. If you wanted to put the pipe functions in there, you could potentially write some other functions as well to go along with your state if you needed to. If you needed something to run sort of fixed update wise, you could add another function in here that potentially calls for this calls for the pipe. Or if you're okay with not using fixed update for the pipe, you could literally just bring this out into another function. So I could bring this out into a void update pipe like this. I'd throw this in here. And so I'd have a function here that I could potentially call on each one of the pipes. It would take a little bit more code because you might have to either loop through all the pipes to make sure they're all moving, or have something with the game manager dealing with that as well. So it can be a little bit more code, but then I could hook this directly into the state. So if I had something like this, I could say for it's I equals 0 to I less than the number of pipes. So I would need to know about the number of pipes. That is another thing. So that's why I'm not going to sort of directly add it in here. But then for each pipe, then I would call update pipe. And so then all of that could be hooked. Update all pipes. All of that could be hooked into the state machine as well, so that as soon as you left play mode, the pipes would no longer update either. So the reason why I'm using that moving Boolean is so that we don't have to write up all that sort of part of it. We don't have to create this and keep an array of all the pipes and stuff, which is what a spawner usually does. A spawner usually keeps an array of all the objects that have been spawned so we can access them. So you may have that anyway, in which case this would be a little bit easier to do. But for now, I'm going to keep it like this. But keep in mind, this could easily be moved into the state machine as well if I had access to the pipes. Yeah, Andy, let's go back to the state machine. Did you just want, Andy, did you just want to play? Okay, so I don't know if this is going to work exactly the way we want, so let's find out. So we're in the scene here. I still don't have gravity on here because we're still just doing some testing. Boom, everything stops. It stopped here because the pipes obviously stopped, but it also obviously triggered the dead, and our spawning was happening because we had our spawn pipes. Since our player died, the player doesn't have to be involved in the state. Let me check pressing the spacebar. This will likely cause something weird to happen because the pipes don't despawn. That's something that we would need to do, which means we would need to keep an array of all the pipes and despawn them all. So destroy them all when we do a reset, which I haven't done. So if I press space, it's probably going to move like one frame and then die again because I'm going to spawn the character right back here. Yeah. So every single time here, it's causing another hit and doing this. So for the pipes, if we want those, just as a quick thing here, if we want those to not be sort of thrown around like that, you should be able to say is kinematic. This little check mark is kinematic, and that should stop it from sort of bumping around like it was doing. So it shouldn't bump. So we still hit, but notice my sort of drone here is moving, but it's not shifting the pipe around. You can think of it as kinematic as it's there, but none of the forces are going to affect it to do anything. So yeah, and as soon as the thing gets put away here, it's gonna as soon as it gets far enough away to not be hit all the time, it'll start running again. There we go. So yeah, so if you don't want your pipe to go, it's kinematic here. Yeah, so the spawning pipe, so that's the key here for the spawning of the pipes, right? So there is nothing in here to say to stop spawning the pipes. It's only this. So every time you call this function, you will spawn pipes. It's the fact that when we die, we leave this state. So we're no longer running this update. As soon as we leave this state and go to the game over state, we're now running this update, which is just checking for a spacebar. So that's why it kind of looks like, well, you should be spawning pipes the whole time, but it's because of the state machine. We move out of the state that can spawn pipes into a state that does not spawn pipes. That's the key to this sort of state machine. So that if you hook everything into your state machine, making a pause game, an overall pause game state is very easy, because then you just make a new state and you move out of the state that's updating the whole game. And if we've sort of had extra time, we would put the pipe movement into the game state as well, so that as soon as we game over, the pipes stop without there needing to be this check here. So then we can completely get rid of the moving Boolean. So adding this stuff into the state machine lets us clean up the game manager as well, so we don't have to have a bunch of state Booleans. We'll still need some, because we need to know the trigger here. So when I should switch states. Well, we won't need a whole bunch for sort of every little piece of every state that we need. We just know that, hey, as soon as this happens, switch states, and we're out. And that can be based on anything. This if statement could be based on the player position. If the player position reaches a certain value, maybe the end of the level, then we need to change state to a loading screen to load the next level, for instance. And so we can do that, and then they're back in the play state, and the location of the player is now back to 0. So then we can keep going and do all the updating we need to do again. So hopefully this helps a little bit. I know that it's not sort of too much different than what we did in class on Thursday, and having our next game use the state machine in a couple of different ways will hopefully reinforce this a little bit further. But this is the idea of the state machine. Take stuff that you're already doing in update in something like a game manager and move it into update in a state machine. And that way, all you have to call is this in your game manager, for instance. And switching states is very easy to do with a Boolean or a key press or whatever it needs to be. All right, so other questions on this sort of state stuff, or any of this, or the spawning stuff, or any other sort of pieces of this? Does this help with the state machine some, sort of maybe getting a little bit, seeing it sort of in action in actual game? Does it help compared to last Thursday? So let's look at the actual Cinema machine again. So I'm going to turn the player back so that gravity is on again. And let's see what this camera's doing. So I feel like it's a little bit tight. and I don't know where I am compared to the pipes. They might be quite a bit lower. Yes, they were quite a bit lower, and we just died. So let's turn off the. Let's make it so this is where sort of cheat code stuff comes in. I might just want to set something where the player can't die. So here I can just, if I just get rid of the stuff in the if statement, and this is where you could add something in, like an invulnerable Boolean or something, so that you can do some proper testing. So I'll just make it so we never leave the state, and I'll probably make the player. We'll turn off the box collider of the player. So that should. There being no background makes it a little bit tough to figure out exactly what's exactly what motion you're doing. So that's something that is actually part of the assignment of this. Make sort of a scrolling background along with this. But from the looks of it, I mean, it feels okay. The camera actually doesn't feel too bad. It could use a little bit more zooming out, but it doesn't feel too bad. It might be stuff might be moving a bit slowly. The gap here, I think, might be a little bit too small. So again, these are just things that you go and tweak. This definitely would be quite a tough game here, the way that it's set up. So I probably would have died on most of these. I mean, the camera kind of looks okay, so we can go look at that camera. So on the Cinemachine virtual camera, this is the thing that you change here. And if you have that highlighted and you're in the game screen, you can see sort of where this is, where everything's sort of pointing and following and all of the stuff. And I don't know why this is different from where I left it last time. Let's move the follow back a little bit. So in the body section, follow offset. If I make this Z more negative, it'll push me back like this. It'll sort of move the camera away from where my object is. So that sort of pulls me back a little bit. And I probably want a little bit of offset, maybe in the negative X. We should be able to do negative X, or are you being a pain here? Yeah, it's been a bit of a pain. I should have had, yeah, that should be okay. I don't know why it's not letting me mess around with the simple offset here. I might have to change like the transform, or maybe the transform on the camera to mess with this. So the Z seems to work fine. Maybe we can do a offset elsewhere as well. Aim-wise, the red area here, and if we click play, we can keep this stuff up as long as we have the VCam selected. The little dot here is where the camera's following. So it's trying to keep aimed at that. The dead zone is where it's allowed to move around and the camera's not going to change its position. As soon as we hit into the sort of lighter blue zone around the outside here, the camera tries to keep track of that. And all of these things like this dampening, horizontal dampening, vertical dampening, that's all how fast this happens. So if I put the damping on the vertical damping here way up, it'll allow me to go further into this blue section because it's going slower to do that aim track. So it allows me to go further in, but it will never allow me to go into this red area. That's sort of that is where it is going to stay. It's going to stay within this red zone guaranteed. Inside the light blue zone, it does this damping thing where you can change the damping to make it either move faster or slower. So a small damping, that yellow dot is only ever going to go a little ways in. I have to really press spacebar to try to get it in a little bit further, and it's tough to do. So you can take this dead zone and you can shrink it, expand it, do whatever you want to with it here. If you take the screen, you can do something like this. So maybe I want the screen a little bit over, like this maybe. Depends. We can expand the soft zone or decrease the soft zone. So that soft zone, that's that. We want to take you down like this. So we have a very small soft zone. We have a little bit more look ahead here. So it might be a little easier for me to see sort of what's going on. Now there is, like I said, there is this sort of look ahead stuff. That's what this the screen was, this sort of screen offset was doing here. So it's something that we may not want. So if we go back here to whatever it was, somewhere around 0.5 for both of these. We shouldn't be able to see the sort of pop-in type stuff that's going on. But we're still sort of middle of the screen, so that might be a situation where we want to still have some sort of shift over. There is the sort of look ahead time, look ahead smoothing, that sort of stuff. So these are just settings that you mess with. So the bias will shift that soft zone around. So it's something that you do have to get a little practice with. You do have to mess around with this a little bit. The exact settings here aren't as important as what the camera sort of feels like. Again, I don't know why it's not letting me do the follow offset in the X or the Y. It's probably, it may have something to do. I don't have any constraints on here though, do I? I have to figure out why that is, because this should give you access to those to change them. Obviously, the Z is able to do it just fine. If you want some other dampening, so the damping here, the damping for the body is not the same as the damping for the aim. So the damping for the body is how aggressively the camera tries to maintain the offset in the Y or the X axis. So if I turn up one of these dampenings, then it'll try to maintain the offset that's listed here. And I guess this is just for Y and Z. It'll try to maintain it. But if it doesn't exactly maintain it, that's okay. And so it just tries to sort of keep up. So it's sort of this delayed camera motion sort of thing. You can think of that as the damping, which is the same here with the horizontal and the vertical. So when you go into the soft zone, it sort of slowly gets you back into the dead zone. So the dead zone, you can move around anywhere you want in the dead zone and the camera won't move. If you think of like a top-down sort of shooter style game, even something like Binding of Isaac, for example. If you're in a room, a single sort of screen room in Isaac, you can move around anywhere in that room and the camera's not going to move. But if you're in a larger room, say you're in one of the rooms that's sort of 4 times the size or one of those L-shaped rooms, then you're going to want the camera to follow, but not be an exact follow. You want Isaac to be able to move around a little bit. And then when Isaac moves into the soft zone, you want it to sort of keep up and sort of do this little sort of slow motion sort of thing over to get Isaac back into the dead zone. So that's the idea of these things. That's the idea of this dead zone, soft zone, and some of the damping, sort of how fast you try to keep up with it. That's the main thing with Cinemachine. You can code all this yourself. These are just actual scripts. That's why everything here is in the inspector. Everything you see in the inspector is just a script. Behind it all is scripts. So you could code something like this yourself if you don't need all these capabilities. But Cinemachine is so useful to get you really good camera controls that I find it basically invaluable. I basically use it on everything. Even if I just have a very simple follow, I'll still use it because it gives you some of that option to have a little bit more smoother camera control than you might otherwise be able to program without a lot of effort, which is quite nice. So again, it's mainly something to play around with. So I go back over to slides. The rest of this stuff is mainly just state stuff. I do want to point out this diagram. It's worth writing out a diagram. If you have a complicated set of states you want to deal with, it's worth doing this. So the little sort of dark dot here is just saying, okay, we're coming into play from maybe we start the game or whatever. So play is going to do all the pipe spawning stuff. A game over would play sound and death animations. Maybe you might have some other stuff happening at game over. You might have that in game manager, but you might have it in the game over one as well. If you had a reset one, so it might be dead equals true gives you this transition. You press a key, it gives you a transition to maybe a reset state. We didn't have that, but that's something that you could access in. And then maybe reset, maybe it's just automatic. It does update like one time maybe, and then it automatically goes back to play, for instance. So if you write out your states like this with what causes their transition and maybe a little bit of notes about them, then you can easily come up with the state classes you need to implement this stuff. If you're actually interested in how I made this diagram, I used Plant UML. It's super useful to generate this sort of stuff. It's not just for diagrams like this. You can make class diagrams and all that kind of stuff. I don't remember if I had in my CS2 classes, I've started doing blackjack, and so I started writing a blackjack game over the course of the semester, and I give a bunch of diagrams and stuff. So if you do want to create some diagrams that are sort of the more sort of professional looking diagrams for a game design document or for a project that you're working on in some other class or whatever, you can make some nice professional looking stuff with relative ease. It's just essentially this is just a text file, and the plant UML will convert it into a PDF. So if you want to make something like this, great. If you want to draw it on a piece of paper, that works too. But it's really helpful in coding up your diagrams. Yeah, so the rest of this is just putting process and update and blah, 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 all that stuff. All right, so your next assignment is to finish the game. So sort of what's next for Flappy Droid, it's up to you. I have the assignment stuff up right now. Remember that the Volcano Island stuff is due tonight, so make sure that that's pushed up to GitHub Classroom, the sort of final version that you want. And you have 2 weeks for this one. So some of the things that you'll be messing around with are stuff like a game over screen. So you'll be able to mess around a little bit with the UI stuff that we did for Volcano Island. Maybe some better graphics. If you want to make some more 3D graphics, you can. Otherwise, things like particle system when you die. The droid or the drone shouldn't just disappear. Right? Particle system and explosion sound. Where would you put that? I put a couple to-dos here in the code that we saw today. Maybe some sound effects, some music. Really, because we didn't go through and do the entire game, this is a chance to make it your own. Throw in some background images, whether they're 3D, whether they're 2D, doesn't matter. Throw something in and have it scroll at a different rate. So we're moving the pipes at a particular rate across the screen. If you have something scrolling in the same direction but slower, that might look like it's a background object. So you can even start with some of the dumb little mountain graphics that I had in Volcano Island. See if you can get it to work. See if you can have a background spawner that spawns other buildings or mountains or clouds or whatever it might be. In a regular sort of Flappy Bird type game, if you go too far down or too high up, you die as well. How can you do that? Think about using, and this sort of one last thing here. Think about using some sort of pane where you throw in a box collider, but you make it a trigger. And you can go in and edit the size, whatever you need to do. Whenever the player hits the trigger, it's going to trigger not on collision enter, but on trigger enter. We saw triggers and collisions in Volcano Island as well. So what could you do here? Score a point. So where could you put that little pane? In the pipe opening. So that when the player hits that collider, it doesn't cause a collision enter to cause you death. It has you score a point. Instead, it does the on trigger enter because our box collider is a trigger for this little like scoring pane. So if you make it through a pipe, you hit this trigger, you get a point. So that's a way you can keep score in the game, for example. So I can talk a little bit about this next week as well, sort of give some hints on some of the other pieces of this, but take a look at the at the PDF. It has all the pieces that are sort of required. So like adding a particle system, that's one of the required pieces for the homework. So you do have 2 weeks to work on that. ND for the PDF for Volcano Island, you want a GDD from scratch. No, there's no need to do a GDD for these. For the games we're working on in class, there's no need to write your own. We will have one more game design document assignment that I will give you a different theme for, so you can get a little bit more practice with that as well. But as far as the games go, you don't need to do it. Main thing I want from like a turned-in PDF is just a little bit of details about what you did to do each of the pieces of sort of what I asked for, and maybe you can say a little bit about how you did it. So it doesn't have to be a long document. I just want to see something saying for for like a death particle effect or something. Like, yeah, we added this particle effect in. It does like a melted cube thing, so it looks like a bunch of squares that are blue or something falling to the ground. So something like that. Something that just sort of describes a little bit about what you did for each one of the little pieces. Lengthwise, I don't have a specific length in mind. For the most part, it could be some bullet pointed stuff. If you want to show a screenshot or something in there, you can throw one of those in. There's not really a specific length as long as it sort of shows what you did. Basically, think of it like this: if a person next semester is taking this class and you handed them what you did for the assignment, they should probably be able to. You don't have to show them code, but they should be able to understand that. Oh, so they added in this thing, or they modified the player script to do this, and so they should be able to see it and be like, all right, yeah, I could probably do that, even without seeing any sort of code or anything. So you don't have to worry about game design document stuff at all. I just want sort of a list of what you did and maybe a little bit of detail about how you did it. That's all. It's not really the main thing is me sort of playing the game and then sort of seeing how it plays. But I do want to see a little bit of specifics about it. And before I let you go, I know it's a minute after right now, but one more last thing before I let you go. We will talk about building. That's something that I have not gotten to yet. You will want to build your games, obviously. So we will talk about that. I don't have a specific lecture to talk about that. So it'll probably be at some point when we have a little bit of time. I will talk about building your projects. It's relatively easy to do. If you want to build for PC, Mac, Linux, this is basically what I have to worry about. The things that you have to remember is you have to add the scenes up here. Whatever scenes you have, they have to be listed in here. And typically, the scene at the top is the scene that you want loaded into first. So if you have a main menu scene, that should probably be the top scene in here. And then all the rest of your scenes can just go in. So if I click add open scenes, here's my main game scene. It's sort of numbered is 0. And now if I say build, it will create the executable for me. And you can do the same thing for WebGL to put it on the website and stuff. So we'll talk a little bit more about that. But if you do want to build a project, you can mess around in the build settings here. And that was just under file. That was under typically they are and under file build settings. So that is it. I will see you guys today, Thursday. I will see you guys next week for some Unity shader graph. That is what is up next. So we're going to make some cool shaders. So PA1 due tonight, PA2 available now, and that's it. So have a good weekend, guys.
Have a good one, Professor. Thank you.
Yeah.
Professor, do you have a second to see why I was unable to add the pipe to the game manager?
Yeah, let's take a look at that.
I can share my screen if you.
Yep. Oh. Yeah, you should be able to now.
So I was trying to drag my prefab and I was just never able to get it in there. And then, like you said, it's just not. There's nothing there for that.
Can you press on the console? Can you press the clear button? I want to see if there's if this is like an error here. Okay. So sometimes it happens when there's errors. Yeah. So that should be hop into your game manager code.
Oh.
And I want you to look at since so you're just sharing Unity. So
sorry.
I want you to look at. Yep. So it is the type that you have for the pipe prefab. So the pipe prefab should be a game object.
Okay.
So right now it was looking for, the reason why I wasn't letting the pipe prefab be in that spot is because it was looking for the script game manager on the object you're trying to drag in. So this time it should work for anything basically.
Okay. Thank you very much. Sorry about that.
Yep. No, that's a perfectly reasonable thing there. And so yeah, so grab wherever your prefab is for the pipe. Yep.
Great. All right. Thank you very much.
Yep. So, yeah.
All right. Have a good one.
Yes, sir. Hendy. I don't know. I saw your little mic thing going, but I couldn't hear.